Hello everyone, today we are going to explain the topic of swap to numbers. So assembly language programming helps in controlling hardware directly. So swapping two numbers means exchanging their values without losing any data. In the 8051 microcontroller, this process is done using registers like the accumulator and simple instructions such as move. Next, this experiment helps us understand how data moves inside the microcontroller from memory to registers and back to memory. So the introduction gives an overview of the concept and why swapping is useful in microcontroller program. Next topic is objectives. In objectives, we learn about first objective is understood how the 8051 stores data in memory location like 78H and 79H. The second objective is to learn how to transfer data using move instruction and registers. The next objective is to perform swapping process correctly without losing any value. So finally, another objective is to observe how the values change during execution using debugging tools. These objectives show what we aim to learn by completion this process.
Hello everyone, my name is Vikas. The first slide is a problem statement. Here we have two 8-bit values stored in memory location 78H, which is contain the first number, and 79H, which contains the second number. Our goal is to swap these two value using the processor register A and B. The important instruction is that we are allowed to use only the move instruction. That means no arithmetic, no logical operation, and no temporary memory location. We must perform the entire swap using data transfer instruction. So overall, the task is to swap the two memory value in the simplest possible way using only move. The next slide is algorithm. To achieve the swap, we follow a very straightforward 5-step algorithm. Step 1, load the value from memory location 78H into the accumulator, which is register A. This saves the first number into A. Step 2, load the value from memory location 79H into register B. Now both number are available inside the CPU. A contains the first number and B contains the second number. Step 3, move the contents of register B into memory location 78. So the second number is now placed in the first number's position. Step 4, move the contents of register into a memory location 79H. Now the first number goes to the second number's position. Step 5, finally stop the program. This step successfully swapped the two values using move instruction as required. Thank you.
Here A and B are the temporal registers and the 78H and 79 are the memory. Here move A, comma 78H means here we are moving the 78H to the address register like load first number, and another move B, comma 79H means here we are moving that 79H memory to the register B, and like we are storing both the values in mode 78H. We are storing that 78 value memory into the second register, and also in another 79H that memory is stored in first register, and the program executes.
Hello everyone. CPC diagram. It describes how data moves between two memory location 78H and 79H and two registers and A and B during execution. Before execution, memory location is 78H as value 25H. Memory location 79H as value 40H. Data flow steps means 78H A. The value at memory 78H 25H is moved into register A. Second step is 79H and B. The value at memory 79H 4DH is moved into register B. Third is B 78H. The value in register B 40H is written back into the memory location 78H. Fourth one, A 79H. The value in register A 25H is written into memory location. After execution, 78H is equal to 40H. Second step is equal to 79H is equal to 25H. In simple words, the value stored in memory location 70H and 79H has been swapped is using temporary storage in register A and B. Thank you.
Good morning, everyone. Myself, Ullas. My topic is swapping two numbers. I am in that I will be telling a result and conclusion. Program successfully swap memory values. That means the code you write to correctly exchanging swap the values stored in a two memory locations. And that I give one example for that. If memory A is equal to 10 and memory B is equal to 20, after the program runs A is equal to 20 and B is equal to 10, and I will tell second point, a verified use key version debug mode. That means you tested that program using a key software, and I will be tell the second point is that debug sure that the swapping works correctly step by step, and will be tell conclusion. Efficient use of a register based data movement. That means you learn how to move a data quickly using a CPU register instead of a memory. This makes the program faster and more efficient. And I will be tell second point, understood accumulator and B register operations. That means the you learned how to import 8051 register A and B work. You also understanding how they help in a arithmetic and data transfer. And I will tell third point, gained hands on a practice in a 805 assembly language. That means you practiced writing and testing a assembly instruction of for the 8051 microcontroller. The improves you low level programming skills. Thank you. Thank you, everybody.
I am showing the COA assembly code. Here I put two values in address 0 into 28 and 0 into 29, 25 and 40. These two addresses are swapping each other. Here we see the both address are swapping each other. The 40 comes to 78H and 25 goes to the 79H. This represent a swap two number. Thank you.